Welcome to the course on applied research from hypothesis to structural equation modeling. In this session, we are going to begin an important discussion that every survey-based researcher must understand: common method bias, often abbreviated as CMB. By the end of the session, you will understand what is common method bias and how to detect CMB statistically using the full collinearity VIF approach in SmartPLS. Common method bias, CMB, refers to systematic measurement error that arises when data for multiple constructs are collected using the same method from the same source and often at the same time, most commonly through self-reported Likert scale surveys. Why do we have to check common method bias, or we also call it common method variance? It is a part of measurement model assessment. It can be told as a prerequisite that we should do to make sure that our data does not have any common method bias. If you have a common method bias, then the loadings as well as the path coefficient will have higher coefficients and higher loadings. In behavioral and management research, this situation is routine. Researchers frequently administer cross-sectional questionnaires in which all constructs are measured on identical 5-point or 7-point agreement scales, which is also a common method. Although method consistently improves convenience and comparability, it can unintentionally inflate or deflate observed relationships among variables. Why does common method bias occur? CMB is primarily driven by response tendencies rather than the substantive relationships between constructs. Several mechanisms explain this. The first one is uniform response patterns. Here, the respondents may unconsciously apply a consistent rating style across items. For example, a respondent in a negative mood may provide lower scores for all the constructs. Some individuals systematically avoid extreme responses so that they want to be in the central tendency bias. And others, most of the time, agree with most of the statements. These tendencies are not necessarily careless responses, rather, they reflect subconscious cognitive shortcuts. Second is cross-sectional data collection. When independent and dependent variables are measured simultaneously, temporary emotional states can influence all responses. Contextual factors at the time of survey completion, like stress, fatigue, dissatisfaction, may affect ratings across constructs. Based on all this, the covariance among variables may reflect shared timing rather than true theoretical association. And the third becomes similar scale formats. Repeated use of identical Likert angles such as strongly disagree to strongly agree for every construct encourages some heuristic responding, which is like many of them half of the time marks 3. May or may not be, they want to be in the central position. And after answering several items, respondents may stop differentiating carefully and instead replicate each ratings, which is like they don't read properly and they don't differentiate it. Rather, they used to give a tick mark for some agreement in the middle. So, fourth comes item proximity and construct clustering. So, here the researchers often group items belonging to the same constructs together, like attitude 1, 2, 3, which appears to consecutively. While the methodological logical, this practice can create usually a perception of repetition and encourage pattern responding. So everything they'll give 5, 5, 5, 4, 4, 4. And it will reduce cognitive effort in differentiating some subtle wording changes. So participants, especially non-academic respondents, may interpret similar items as redundant rather than psychometrically necessary. So what happens statistically when there is a problem with CMB? When CMB is present, the correlation may be artificially inflated. Structural paths in SEM may appear stronger than they truly are, and the model fit indices may be misleading. and discriminant validity may appear compromised. In essence, the shared method variance contaminates construct variance. So normally there are some example scenarios if there is a study on customer satisfaction or perceived quality or on brand trust, and if they are being assessed using 7-point Likert scales in a single questionnaire in the same sitting with similar agreement based wordings everywhere for all the questions, your respondent in a temporary negative mood may score all three constructs low, and the resulting correlation among these variables may partly reflect mood driven uniformity rather than actual conceptual relationship. A key definition, when you want to conceptual definition of CMB or common method bias, arise when the variance attributable to the measurement method rather than to the constructs the measures represents. So this distinction is crucial in behavioral finance, marketing, organizational research, and psychology fields, where the self-report surveys dominate. So why it matters in research design? The failure to address CMB may always threaten some internal validity, inflate causal interpretations. It may lead to incorrect theoretical conclusions, and particularly in cross-sectional survey-based research, which is very common in management and behavioral sciences, CMB must be considered at the design or data collection or in the analysis stages. So how can you avoid this CMB? You can use some procedural remedies like design stage, strongest protection can be given. You can also, in design, remedies are always preferable. Once the bias enters the data, it cannot be completely removed. And you can also ensure psychological anonymity, which is like anonymity should be reduced in social desirability bias, evaluations, extreme response avoidance. Okay, and when respondents feel identifiable, especially in physical data collection settings, they tend to moderate some responses. Even if the names are not recorded, the mere presence of the researchers can suppress the honest reporting of the respondent. So it is always like physical data collection does not give more amount of original feelings or original data, what we practically expect. So the best practice can be do not collect identifying informations like name, emails, phone numbers unless it is absolutely required. And you can use some online anonymous surveys where possible and explicitly state that responses cannot be traced. So this step alone will reduce socially desirable responding significantly. Then you can also have some separate measurement of predictor and criterion variables. There can be the temporal separation weakens the respondent's ability to mentally connect the constructs. So you can collect independent variables in time 1 and collect the dependent variables in time 2. That will have a time lag design. So even a 2 to 4 week gap reduces the consistency motifs. And normally here the limitations are it requires recontact anonymity may become challenging normally because you have to go to the same person at time 2 and collect the data. So that is actually anonymity once and it is a limitation. And you can also do the source separation, collect data from different sources, independent variable from employees and dependent variable from supervisors. So this multi-source design are highly effective in minimizing the CMB because the shared rater bias is normally eliminated here. And this approach is widely recommended in organizational research. And when you are using some identical Likert anchors repeatedly, it encourages heuristic responding. So instead of strongly disagree and strongly agree for all the construct, you can also use some variations such as very unlikely, very likely, never, always, or not at all true, completely true, poor and excellent. These type of variations can also be tried. Changing angles forces cognitive rearrangements, normally contrary to this common misconception that all scales must be identical. The methodological diversity can reduce systematic bias, and uniformity normally aids the analysis and it does not necessarily enhance validity. So that you can also have some counterbalance or randomize the item order to avoid some clustering all items of a construct together. You can also do some randomized items or intermix constructs. When items are grouped like attitude 1, attitude 2, attitude 3 together, respondents may perceive the redundancy and replicate ratings mechanically. So item separation reduce the pattern responding. Normally you can have your first attribute, first question in the first question, and the attribute third somewhere where it is not related to attitude questions have been asked. There also you can place it. Next comes improve item wordings. So you can avoid some ambiguous wordings or double-barreled questions, repetitive phrasings that can be avoided. And minor wording differences are not sufficient. Conceptual clarity matters, and poorly differentiated items invite automatic responding. Then comes your reduction in evaluation apprehension. So we can assure that the participants that there are no right or wrong answer, and there is honest responses are valuable, and the results will be aggregate that can be told to them. When the respondents feels judged, they regulate their answers towards more of socially acceptable positions. So to collect the original data, we can tell the respondents related to how we will be doing the how we are going to evaluate, or we are not going to judge them. Such type of things can be told to them. So there are also statistical remedies can be given, like post data collections. These methods do not normally eliminate the CMB, but they can only detect or estimate it. So there is a test known as Harman single factor test. So all items are entered into an exploratory factor analysis, and without any rotation we have to run the EFA. If one single factor explains greater than 50% of the variance, then there is a potential for CMB concern. However, this test is widely criticized as insensitive, and now in many journals also they ask you to do any other methodology if you do only Herman's single factor test. Next comes common latent factor CLF approach or CFA approach. So here you can add a latent factor loading on all indicator, which is like standardized loadings change substantially after including CLF. So you can find that there is a CMB find. CMB is present and more rigorous than Harman's test. Next comes marker variable technique, which include a theoretical unrelated variable in the questionnaire, which is the marker variable we tell. We run the model once with the marker variable and once without the marker variable. Now we will check the difference or changes in the coefficients. If the marker variable correlates strongly with substantive constructs, shared method variance may exist. So you can ask some question which is not at all related to this questionnaire. And fourth comes your full collinearity VIF, which is again using your PLSM, which has been proposed by Netcock. So if your VIF is greater than 3.3, there is a possibility of CMB. Commonly, which is a method which is used when you are doing your analysis with SmartPLS. Now let's walk through the complete procedure of detecting common method bias and using the full collinearity VIF approach in your SmartPLS. You can follow the steps carefully and pause the video whenever you need to practice. We begin with a raw data file that was previously downloaded from SmartPLS. Typically, this file is available in CSV format. When you open the CSV file directly, you may notice that the entire data set appears in a single column. This is normal. We will correct this by using Excel. So we can close the CSV file and open Microsoft Excel. So now you can close the CSV file and open the Microsoft Excel. Go to data in Microsoft Excel and then you can click get data. Here you can choose or from text or CSV, as our file is in the form of CSV. Now you can select your CSV from the location where it has been available. And Excel will automatically detect the delimiter and preview the data set in proper column format. Once you confirm that the data is correctly arranged, then you can click load. If you think that it is not in, your delimiter has not been identified, you can manually also do it. So now save this file in Excel format. This step is very important because we will be adding a new variable. Next, we can create a new column, name it as random. In the first cell, with this column, type the formula is equal to rand open bracket and close bracket. Now you can press enter. So Excel will generate a random number between 0 and 1. Drag the formula down to populate all the rows. You will notice that each time you refresh or reopen the file, the random numbers change. This is an expected behavior. So before importing into SmartPLS, convert the formula into fixed value. To do this, always copy the entire random column, right click it and choose paste special, where you will be finding values and you can type it down. Where you will find values and you can just now the random numbers are stored as actual values, not formulas. Save the file again. Now return to SmartPLS. You can go back to your workspace and create a new project. Name the project as CMB. Import the updated Excel dataset that contains the random variable. During import, verify the random column appears correctly. Once it is confirmed, then you can click import. After importing, you can open the data view and check whether the random variable contains the numeric value. If everything looks correct, proceed to model creation. Click create model. You can choose PLSM as the model type and the name in the model as CMB. You can save it. You will now see a blank canvas. For the common method bias test, we treat the random variable as the dependent construct, and all other Likert scale construct in the questionnaire becomes an independent construct. So drag and drop each construct into the model. Here you can see that ATTR represents attractiveness, COMP represents competence, CSOR represents corporate social responsibility, CUSA represents customer satisfaction, CUSL represents customer loyalty, QUAL represents quality, CE represents customer engagement, trust represents customer trust, SE represents switching cost, and we are not supposed to include any demographic or objective variables such as the relationship, age if they are not measured using Likert scale. Once all the constructs are placed, press your Ctrl A, right click and select the hide indicators. This simplifies the visual layout since we are not presenting this diagram in our paper. So this visual layout is easy for you to manage, and we are not using this in the paper to show any analysis. This is only to be done to identify the CMP value. So you can always hide indicators. Now you can arrange the constructs neatly and place the random construct separately as the dependent variable. Now you can click on connect tool and draw the arrows from each independent construct to the random construct. Once all the arrows are drawn, the model is ready. It converts into blue color to show that the model is ready. You can now click calculate and choose the PLSM. Keep all your default settings like your weight scheme to path, results to standardized, and your initial weights as default. Now you can click calculate. After the model runs, you can go to quality criteria and then collinearity statistics and select your inner model. After the model runs, go to quality criteria and then collinearity statistics and select inner model list view. Here you will observe that the VIF values for each construct predicting the random. So according to the threshold proposed by NetCock 2015, VIF values should be below 3.3 to indicate that common method bias is not a serious concern. If all the values are below 3.3, you may proceed confidently with your main SEM analysis. If certain construct shows values slightly above 3.3, inspect those constructs carefully. Values above 5 indicates there is a serious multicollinearity concern and may require further investigation of items, redundancies, or some construct overlap. To save your results, you can click the save icon. This saves the output within SmartPLS. For backup, normally they export the results to Excel. Click the Excel icon, choose export and select your preferred save location. The Excel file will contain all the output sheets. Navigating to the Collinearity statistics sheet to view your VIF values you can do. Once the CMB assessment is complete and documented, you can return to your main model and continue with structural modeling evaluation. Normally saving in Excel is very good because even if you do not have your login credentials, or if you have lost your 30 days trial version, the Excel will always be remaining over there. So this is the complete procedure for detecting common method bias using full collinearity VIF approach. Thank you.